Hello, everybody. Welcome back. Today, we will be going over Chapter 3, and the main topics that we'll be looking at are producing data, sampling design, and designing experiments. And so before I begin with these three topics, let me remind you a few of the terminologies that we have seen before. The first one is that of population. So recall that the population is the set of all measurements for the entire group of cases. So for example, let's say we are looking at whether voters prefer or favor President Trump in the 2020 election. So in that case, the population would be the set of all responses, of all the voters in the United States. What is a sample? A sample is basically a subset of the population. So maybe in order to estimate what proportion or percentage of voters favor President Trump, we pick a sample of voters. Let's say a sample of 2,500 voters, and then ask them who they favor, and so the responses from the voters in the sample, that's going to be a subset of the population. Again, the idea is to use a sample in order to say something about the entire population. How well a sample represents the population depends on the way the sample was obtained. That is, it depends on the sample design. A parameter is a number based on the entire population. So again, if we are interested in President Trump's favorability in the 2020 election, then we said that the set of responses of all the voters. So maybe what we are measuring is whether voters favors President Trump or not. And the set of responses for all the voters would be the population, and the proportion or the percentage of all the voters who favor President Trump in the 2020 election would be called a parameter, because that proportion is based on the entire population. On the other hand, a sample statistic is a number that is based on a sample. So again, looking at the 2020 election, whether voters favor President Trump, in that case, if we pick a sample of say 2,500 voters, and ask them whether they favor or not favor President Trump, and based on that sample, if we see, so the proportion of voters in the sample who favor President Trump, or the percentage of voters in the sample who favor President Trump would be a sample statistic. So we use the proportion based on the sample as an estimate for the proportion for the entire population of voters. So a statistic is basically an estimate for a parameter. So if we are collecting data for answering certain questions, the first thing we want to do is look to see if look to see if the data is already available, right? So the library and the internet are sources of available data. Now, the government statistical agencies maintain demographic, economic, and social data. You may visit the FedStat site at fedstats.gov. There are, you can find a lot of finance data at finance.yahoo.com. So Yahoo Finance gives you a lot of information about a lot of data on stock market and so on. The Bureau of Labor Statistics, that's a great place to find data. The National Center for Health Statistics, that would be another place for health-related data. Okay, so if we don't have the data available, then we have to do something to find the data. Okay. A kind of data is called anecdotal data. This is anecdotal data is data that you really see in everyday life. Your friends and family, your co-workers, they are always throwing this anecdotal data at you. So anecdotal data is based on individual examples and may not be representative of the larger group of cases. So here's an example of an anecdotal data. A few years ago, one of my friend, he had a friend who lived in who had a family member who lived in UK, and he was telling me that his family member living in UK said their healthcare system is horrible, and therefore he came to the conclusion that the healthcare system in UK is horrible, and so basically his conclusion is based on one person's experience. So here is another example. So a couple of years ago, also I was reading an article where this student from US, he went to Germany to attend one of his friends' wedding there, and when he was there, he got hurt. He had an accident where he probably twisted his ankle, and then he was talking about his experience in visiting the emergency hospital and the doctors in Germany, and how he thought their healthcare system was really great. So again, that is also an example of an anecdotal data because that is just one person's experience. So what I'm getting at is that individual examples don't tell us about the overall trend of the phenomenon that we are looking at. Here are a couple of other examples. Most of my friends are Republicans, and therefore most of the voters in my town are Republicans. I have driven my Honda Accord for 200,000 miles with only usual service maintenance expenses. So all Accord owners have the same experience. Bob has a severe cold. His roommate takes a garlic tablet every morning and has not had a cold in 2 years. Bob's aunt also has a friend who takes garlic tablets daily and has not had a cold in more than a year. Based on this data, Bob decides to start taking garlic tablets as soon as his cold clears up. So these are all examples of anecdotal data. Again, more often than not, the anecdotal data will not be representative of the larger group of cases. If available data does not help us answer objective questions, then we need to produce data to answer them. And then the question is how to design a study to produce data. There are two main types of studies: observational and experimental studies. Observational study. So in our observational studies, we observe the response of a specific variable for each individual or object without attempting to influence the responses. So, which means that no conditions or no treatments are imposed on the individuals or objects to cause changes in the variable. That is, we don't do anything to cause changes in the response. A cause and effect relationship revealed by an observational study is generally considered weak. So to study cause and effect relationship, we shouldn't be using observational studies. The required time in many observational studies could be very high. It is less expensive than experimental studies. Opinion surveys, census, they are examples of observational studies. So here are some more examples. Suppose we want to investigate the proposition that female crickets, those of you who don't know, crickets are a kind of insects. So female crickets choose their mates on the basis of their health. In this case, one simply observes the health of male crickets that mated. So the researcher can just go ahead and just observe the health of male crickets that mated. So here in the first, the researcher is only observing. He is not applying any treatment or any type of conditions on the environment to cause changes in the variable that he is studying. Here's another one. Do baseball players have strong bones in their throwing arms? To answer this question, we pick a group of baseball players and measure the strength of the bones in their throwing arms. We also pick a control group of subjects who we match with the best baseball players based on age and measure the strengths of the bones in their throwing arms. This is not a sample survey. Is this an observational study? And the answer is yes. This is an observational study as well, even though it's not a sample survey, because in this case we are not doing something to the cases or the subjects of study to cause changes in the variable. So in other words, no treatments have been imposed in this study. Okay, now experimental study. In an experimental study, a deliberate treatment or a condition is imposed on individuals or objects, and the response of a specific variable from the treatment is measured and recorded while influential factors are controlled. Typically, individuals are randomly assigned to two groups, a experiment group that receives the treatment and a control group that doesn't receive the treatment. A cause and effect relationship revealed by an observational study is generally considered weak. Shorter required time than that of observational studies. Typically very expensive. Only experimental studies can be used convincingly to draw cause and effect relationship. Some examples. So remember the example where we looked at we were investigating whether female crickets choose their mates based on the basis of their health. So one way to do an investigation here is just simply observe the health of male crickets that mated. Now, so that would be an observational study if we just do that. But we can also do an experimental study in that case where we deliberately infect some of the males with intestinal parasites and see whether females tend to choose healthy rather than the ill males, right? So here, since we are imposing a treatment in some of the objects, this would be an experimental study. Here's another example. So does sleeping at least 8 hours before the exam day more likely help a student get a good grade? Does sleeping at least 8 hours before the exam day more likely to help a student get a good grade? So one way to answer this question is to do the following study, which would be an observational study. Randomly select a sample of students and give them a survey on how many hours they slept before the exam day and the grades they received, right? So this would be an observational study to answer this question. But we could also do an experimental study where we randomly assign students one of two groups. Group 1 has to follow a strict study schedule, and group 2 is asked to follow their usual routine. So group 1 will be prescribed a specific routine of studies. So they have to, let's say, sleep at least 8 hours and so on. A group must follow a prescribed schedule. The other group doesn't follow this prescribed schedule, and then after that, after the exam, we compare the grades of the grades of the students in the two groups. Okay, here's another example. In order to determine if smoking causes cancer, researchers surveyed a large sample of adults. For each adult, they recorded whether the person had smoked regularly at any period in their life and whether the person had cancer. They then compared the proportion of cancer cases in those who had smoked regularly at some time in their lives with the proportion of cases in those who had never smoked regularly at any point in their lives. The researchers found a higher proportion of cancer cases among those who had smoked regularly than among those who had never smoked regularly. What type of study is this? So you should pause, read through the example a couple of times, and figure out whether this is an observational study or an experimental study. Okay, I hope you paused and thought about it. The answer is this is an observational study. The reason is even though we divided the subjects into groups here according as who smoked and who didn't, but here we just did a survey, so we didn't impose any type of treatment to the subjects in this study. So this is an observational study. Another example, a study is designed to determine whether grades in a statistics course could be improved by offering special review material. The 250 students enrolled in a large introductory statistics class are also enrolled in one of 20 lab sections. The 20 lab sections are randomly divided into two groups of 10 lab sections each. The students in the first set of 10 lab sections are given extra review material during the last 15 minutes of each weekly lab session. The students in the remaining 10 lab sections receive the regular lesson material without the extra review material. The grades of the students who reviewed weekly were higher on average than the students who did not review every week. What type of study is this? So again, go ahead and pause, think about the example, and come up with your own answer before you proceed. So hopefully you have answered the question. So in this case, notice that a group of students we imposed a treatment to a group of students, which is basically that they had to do this extra review material every week. So this will be an experimental study. Another example, in order to assess the effects of exercise on reducing cholesterol, a researcher sampled 50 people from a local gym who exercise regularly and 50 people from the surrounding community who were assumed do not exercise regularly. Each subject reported to a clinic to have their cholesterol measured. The The subjects were unaware of the purpose of the study, and the technician measuring the cholesterol was not aware of whether the subjects exercises regularly or not. What type of study is this? Again, go ahead and pause and come up with your own answer before you proceed. Okay, so hopefully you had your own answer. The answer in this case is that this is an observational study, and the reason is here the researchers simply are they are simply observing the so the point is the researchers themselves did not prescribe a treatment or to the subjects. So because of that, this is an observational study. A researcher is studying the relationship between sugar consumption and weight gain. 12 volunteers were randomly assigned to one of two groups. The first group of 5 participants was put on a diet low in sugar, and the second group of the remaining 7 participants received 10% of their calories from sugar. After 8 weeks, weight gain was recorded from each participant. What type of study is this? Well, in this case, notice that the researcher has prescribed the participants to do something. So something was done, some treatment was done to the participants. So this is an experimental study. Which of the following statements best describes the difference between an observational study and an experiment? In an experiment, a researcher is careful to determine exactly what is to be observed, whereas in an observational study, there is greater concern about how the observations are made. In an experiment, the data are obtained using careful controls on the treatments, but in an observational study, the data are obtained through careful observation of responses. In an experiment, treatments are deliberately imposed upon individuals and their responses are observed. However, in an observational study, without any attempt to influence the responses, individuals are observed and variables of interest are measured. There are really no significant differences between the observational studies and experiments. They are different names for essentially the same type of study. Okay, so A, B, C, D, which one would you pick which one best describes the difference between the two types of studies? Okay, so the answer in this case is C. Sickle cell disease is a painful disorder of the red blood cells that in the United States affects mostly African Americans. To investigate whether the drug hydroxyurea can reduce the pain associated with sickle cell disease, a study by the National Institutes of Health gave the drug to 150 sickle cell sufferers and a placebo to another 150. So I'm going to describe to you what a placebo is in a bit. It's basically 150 of them received the drug and 150 of them received a fake drug. That is a kind of like a sugar pill that's not really the drug. Is so that the subjects don't know whether they got the drug or not. Well, so a placebo is given to kind of make sure that the response that you see is actually due to the drug and not to the some sort of perceived belief of the patients. Okay, again, I'm going to describe in detail what that is in a bit. And so the researchers then counted the number of episodes of pain reported by each subject. And what is the response variable in this case? Well, clearly the response is the number of episodes of pain. Confounding and lurking variables, again, we have looked at them before. When the effects of two variables on a response variable cannot be distinguished, they are confounding variables, and defeating confounding variables should be a goal in designing experiments. For example, cell phone use versus brain cancer. The possible lurking variables could be age, occupation, and the place of residence. A group of college students believes that herbal tea has remarkable restorative powers. To test its theory, the group makes weekly visits to a local nursing home, visiting with residents, talking with them, and serving them herbal tea. After several months, many of the residents are more cheerful and healthy. What is the lurking variable in this experiment? A, the emotional state of the residents. B, herbal tea. C, the fact that this is a local nursing home. And D, visits of the college students. Well, the answer is D, because the nursing home residents, we're looking at whether herbal tea affects the nursing home residents in a positive way. That is, if it makes them more cheerful and healthy. Well, one of the reasons for them to be cheerful, it could be that these college students are visiting them. Okay, some terminologies, experimental units. These are the individuals on which the experiment is done. They are called subjects if they are human. A treatment is a condition that is imposed on the subjects, and the factor is a explanatory variable in the experiment. Outcomes, the measured variables used to compare the treatments. The treatment may be it could be the administration of a drug. It could be following a specific diet or a specific exercise program. It could be completing a prescribed activity. So, so for example, let's say we are trying to study the effect of diet exercise program on blood pressure. So group one will have people on the diet or the exercise program for, let's say, 6 months. Group two, the people in group two who don't diet or exercise. So then we compare the blood pressure, which is the response variable here, the blood pressure measurements of group 2 with that of we compare the blood pressure measurements of group 1 with that of group 2. Level, a specific value of the level means it's a specific value of a factor. So for example, if we give 2 different doses of a drug in the experiment, then we say that we are testing 2 levels of the factor. So in the study of sickle cell anemia, the subjects are the patients. Let's say we have 300 patients. The factors are treatments, so hydroxyurea and the placebo or dummy pill. So those are the factors, and the response variable would be the number of episodes of pain. And in group 1, you will have 150 patients who were given the drug hydroxyurea, and 150 were given a placebo or a dummy pill. Controlled environment or lab. So this would be, if we are carrying out the experiment in a controlled environment, such as a lab, then we can expect less effect of lurking variables. But if we are carrying out an experiment outside a controlled environment, or we're doing the experiment in an uncontrolled site, then there is a higher likeliness of lurking variables. Comparative experiments. So these are the experiments where we compare the response to a treatment to another treatment, no treatment, a control, a placebo, or any combination of the above. To avoid confounding, one should always use comparative experiments. So again, comparative experiments are those experiments where not only a treatment is imposed to subjects, we also divide the subjects into groups, and where one or more of the groups receive the treatment, the other groups will contain maybe another treatment or no treatment or a placebo or some combination of those, and then we compare the results from the groups. Okay, so now let me go in detail about placebo effect. The placebo effect refers to the apparent health improvement not due to any treatment, but due to a patient's perceived belief in improvement. So for example, so my mother's doctor, the diabetes doctor, basically. So whenever she visits him, she already feels better. So that's like a placebo effect. The placebo effect is believed to have therapeutic results on up to 35% of the patients. It can sometimes ease the symptoms of asthma pain to high blood pressure and even heart attacks. Among patients who believe their health will get worse, an opposite or negative placebo effect may be observed. So, some of the, our everyday life, we see placebo effects, like, so let's say, when my son, let's say, gets hurt in the eye, and then I, look into his eyes, I kiss him, I hug him. Those are, and then he feels better. I mean, those are signs of placebo effects. So in clinical studies, there is you sometimes give a group of people, group of subjects, you give a drug, and another group of subjects you give a sugar pill. That is, all of them, they think that they are getting the drug, whereas one group didn't get the drug. And the reason is to make sure that the effect that we see in the response is not due to placebo effect. So sometimes patients feel better because when they take pills. Control refers to a component of an experiment where no treatment is administered in a group of cases to serve as a reference mark for the actual treatment. A placebo is a dummy treatment, such as a sugar pill. A placebo is given to ensure that the response to the actual treatment is due to the actual treatment and not the subject's apparent treatment.